Okay, the next question on the exam paper was a general solution to an equation that we gave you to solve. Now folks, again the same thing. You have to analyze what it is that you want to solve, the thing that we give you. And notice that this one was also just for 5 marks. We asked you for the general solution correct to 1 decimal place. Okay, so we've got quite a few things that we can do here, but the one thing we are not going to do is expand these angles. It is unnecessary. It is a 5-mark question, folks. It should be done in 4 to 5 steps maximum. Okay, so let's see what is the trick here. Well, look at this. We've got a relationship for sine and cos. Now I'm going to explain what those relationships are. It could be a co-ratio relationship, or what we call a complementary relationship, which would mean that if that was the case in this question, we had to have the same coefficients, which we don't have. We don't need equal angles. Now, if we look at the angles are equal. So there's another relationship, and that is the quotient relationship. Now, by that I mean you've learned that the tan of theta is the sine of theta over the cos of theta. But now there's one thing that I need to draw your attention to. To be able to draw onto that relationship, you have to have your angles the same. The coefficients of the ratios does not need to be the same. The angles need to be the same. So look at that. It's not going to be complementary because the coefficients are different. Okay, but what am I going to do? I'm going to say this is the sine of 2x, which is equal to minus 3 times the cosine of 2x. And now I'm going to combine these two in the quotient identity. Sine 2x divided by cos 2x will then be minus 3. Sorry, and that then shows that this reduces to the tan of 2x, which is minus 3. And now I can apply my definition. I can say, okay, that would mean that 2x would be the inverse tan of the negative 3 plus multiples of the period for tan. Remember your rule. I'm going to write it down here. If the tan of theta is equal to a number k, then to get to the theta, I inverse tan the number k and I add multiples of the period for tan, where this n is an integer. Okay, so all I need to do now is go to my calculator. Now AP Maths students, remember to check that you're not working on radians but on degrees. So I go second function tan of the negative 3, and I tell my calculator to ask it to tell me what it is, and that gives me minus 71,56 degrees plus multiples of 180, which is equal to 2x. Don't forget your therefores as well. Okay, so all that's left now is for me to take that 2x and divide it by 2, and I get x is equal to minus 35,78. I'll do the rounding just now, and all of this is divided by 2, including the period of the curve. Okay, so they asked me correct to 1 decimal place, so x becomes minus 35,8 degrees plus multiples of the 90, where n is an integer. And there you have solved found your general solution correct to 1 decimal place. Now folks, some of you went off the rails here. Some of you expanded the 2x and expanded the cosine of 2x and then ended up with a quadratic trinomial. Not a problem. It's not wrong. It's just too long. You want to get to your solution in the quickest way possible. And in here I chose tan. Why? Because the ratios were sine and cos, and the angles were identical angles, so I did not have to expand. So don't always, if you see a double angle, think that you have to expand it. It's not true. It will get you to the right answer, but you will just have quite a few more steps.